Every year, hundreds of aircraft quietly disappear from the skies, not because they are useless, but because their time is up. And while most people imagine them abandoned in endless deserts, the reality is something far more intense. Behind the scenes, these massive machines are taken apart piece by piece inside industrial facilities, where millions of high-precision components are recovered, processed, and prepared for a second life. This is not destruction. This is transformation on an enormous scale. In this documentary, we take you inside a large-scale aircraft recycling operation where engineering precision meets heavy industry. From the moment a retired aircraft arrives, every step is carefully planned. Inspection, dismantling, material separation, and high-temperature refining. Nothing is random. Nothing is wasted. Watch how entire airframes are systematically broken down and reborn as valuable industrial materials in one of the most efficient recycling processes in the world. The process begins the moment a retired aircraft arrives at the recycling facility. These planes are often transported to dry regions, where low humidity helps preserve their structure before dismantling. At first glance, the aircraft may look complete, but inside a detailed evaluation is already underway. Engineers carefully inspect every section of the fuselage, wings, and internal systems, identifying which components can be reused, refurbished, or recycled. Each part is documented, tagged, and entered into a tracking system, because even after thousands of flight hours, many of these components still hold significant value. This stage is not about speed, it's about precision and understanding exactly what the aircraft still has to offer. Before any cutting begins, the aircraft must be carefully stripped of its most valuable and sensitive components. Technicians start by removing engines, avionics, wiring systems, and cockpit instruments, each one handled with extreme care. At the same time, all hazardous materials such as fuel residues, hydraulic fluids, and pressurized gases are safely drained and contained under strict protocols. This stage requires both technical skill and patience, because every removed component represents potential reuse. Some will be refurbished and installed on other aircraft, while others will be sold as spare parts across the global aviation market. Before the aircraft structure is cut apart, another critical phase takes place inside the cabin. Crews move through the interior, systematically removing seats, overhead bins, insulation layers, wiring panels, and flooring materials. At first glance, these elements may seem insignificant compared to engines or landing gear, but in reality, they represent a massive volume of recoverable material. Fabrics, plastics, and composite panels are carefully separated, while copper wiring and electronic components are extracted for further processing. Even the smallest parts are not overlooked, because at this scale, efficiency depends on recovering everything that still holds value. By the time the stage is complete, the aircraft is no longer a passenger space. It has been reduced to a hollow shell, ready for structural dismantling. With all critical components removed, the focus shifts to the aircraft's structure. Massive industrial tools are brought in to begin dismantling the airframe itself. Wings are detached, landing gear is separated, and large fuselage sections are cut into manageable pieces. Despite the scale, every movement is controlled and deliberate. This is where engineering meets raw mechanical power, where machines designed to withstand extreme conditions are carefully taken apart without unnecessary damage to the materials inside. Each section is then transported to the next stage for further processing. At this stage, the aircraft is no longer a recognizable machine, but a complex mix of materials. Large sections are fed into industrial shredders, breaking them down into smaller fragments. These fragments are then sorted using advanced systems that separate aluminum, steel, titanium, and composite materials. Precision is critical here because even small contamination can reduce the value of the recovered materials. Magnets, sensors, and automated sorting lines work together to ensure each material stream remains pure and ready for refining. Before the separated materials can be melted and refined, they must go through a critical preparation phase. At this stage, metal fragments and components are thoroughly cleaned to remove coatings, paints, sealants, and any remaining contaminants left from years of operation. Specialized processes such as chemical washing, thermal treatment, and surface stripping are used to ensure that each material meets strict industrial standards. This step may seem subtle compared to heavy shredding or cutting, but it plays a decisive role in the final quality of recycled materials. Without proper cleaning, impurities can compromise entire batches during melting. By the end of this phase, what remains is no longer just scrap. It is a controlled, high-quality input ready for precision refining. Once separated, the materials enter the final stage of transformation. Metal fragments are melted in high-temperature furnaces, where impurities are removed and the material is refined to industrial standards. What was once part of a massive aircraft is now reduced to raw material, ready to be reshaped into new products. Aluminum may become automotive parts, construction materials, or electronic devices, while other components may return directly to the aviation industry. In the end, up to 90% of an aircraft can be recycled or reused. This is where the process comes full circle, turning what could have been waste into something valuable once again. After refining, the materials are not immediately shipped out. They must first pass through strict quality control. Samples are tested for purity, strength, and consistency to ensure they meet industrial standards. Advanced inspection methods, including spectrometry and stress testing, verify that recycled metals perform just as reliably as newly produced materials. Only after passing these checks are the materials approved for reintegration into global supply chains. From here, they are transported to manufacturers across multiple industries: aviation, automotive, construction, and electronics, where they become part of entirely new products. This final stage completes the cycle, turning recycled output into real-world application. What once carried passengers across continents at 30,000 feet above the ground does not simply disappear when its final flight ends. Instead, it enters a new phase where every section is carefully inspected. Every component is dismantled, sorted, cleaned, refined, and tested with precision before being sent back into the world again. No longer as part of an aircraft, but as materials and systems that will quietly integrate into new industries, new structures, and new purposes, from infrastructure and transportation to everyday objects we rarely question. Because inside these massive factories, nothing is left to chance and nothing is truly wasted. Every fragment is tracked, every alloy is recovered, and every usable part is given another life, turning what could have been industrial waste into something valuable once more. And in that transformation, we begin to understand that the end of an aircraft is not a moment of loss, but a process of continuation, where engineering meets sustainability, and where one of the most complex machines ever built is slowly reshaped into countless new forms. Proving that in modern industry, value does not disappear over time, it simply moves, adapts, and evolves into something new.